By every modern assumption, this should not exist. A 1,000-ton figure stands on a mountain peak above Rio de Janeiro, arms stretched into violent Atlantic winds, exposed to storms, lightning, salt air, and gravity itself. It looks calm, balanced, almost weightless. But that is the illusion, because this is not just a statue. It is over 1,000 tons of reinforced concrete, shaped into a cross, standing on an isolated granite summit nearly 700 meters above sea level, where winds can exceed 200 kilometers per hour. That shouldn't be possible, and the deeper you look, the less sense it makes. How do you build something this large, this exposed, in the 1920s, on top of a mountain, and make it survive for nearly a century? And this is where it begins to get strange, because nothing about this project should have worked. In 1921, Brazil wanted a symbol, a monument for independence. The location? Corcovado, an isolated granite peak rising out of dense rainforest, wrapped in clouds, hammered by Atlantic storms. Visually perfect, logistically absurd. That's the first contradiction. Almost no access, yet massive ambition. Engineer Heitor da Silva Costa won the project. His original idea, Christ holding a cross and a globe. It failed, publicly mocked. But that failure created the breakthrough. The statue wouldn't hold the cross. The statue would become the cross. Simple idea, extreme consequence, because now those outstretched arms aren't decoration. They are structural liabilities, catching wind like giant sails. So the question gets worse. How do you stop a cross-shaped structure from being ripped apart by mountain-level wind forces? The answer starts with a decision that made no sense at the time. Reinforced concrete. Verified evidence shows steel, the obvious choice, would have corroded quickly in the salty coastal air. Concrete offered durability, but it created a bigger problem: precision. How do you shape, pour, and control massive concrete structures at altitude, in unstable weather? With 1920s technology? The explanation exists, but it makes the achievement even more impressive. French engineer Albert Caquot calculated not just weight, over 1,100 tons, but wind pressure hitting those arms like a wall, and the numbers make it worse, because wind doesn't just push, it twists, it vibrates, it destabilizes. So the structure had to be rigid, but also intelligently distributed. Meanwhile, in Paris, sculptor Paul Landowski was solving a completely different problem. Human expression. He created the head and hands at full scale, the head alone nearly 4 meters tall, each hand massive, yet required to feel human. These models were then cut apart, piece by piece, shipped across the ocean, and reconstructed on a mountain. That's the next contradiction: monumental engineering, assembled like a fragile sculpture. Each piece had to fit perfectly onto the internal framework. A misalignment of millimeters at the base could mean meters at the summit. And if that sounds difficult, it gets worse. There were no roads, no trucks, no storage space. Everything, cement, sand, water, scaffolding, molds, had to travel up a small railway. Limited capacity, constant delays. The entire construction site had to function like a living system. What arrived in the morning had to be used the same day. Imagine it, workers hanging above a vertical drop into rainforest, clouds rolling through the structure, surfaces slick with rain, visibility disappearing in seconds. And here's something that feels almost impossible. Despite the danger, there were no recorded fatalities during construction. 9 years, extreme conditions, 0 deaths. That alone would be extraordinary. But then there's this. What looks like a solid monument isn't. It's hollow. Inside is a complex network of pillars and beams, more like a vertical building than a statue, anchored deep into the mountain's granite core. A narrow staircase runs inside it, from the feet to the arms to the head. And inside the chest, hidden from the world, Silva Costa added something unexpected: a small, heart-shaped detail, carefully crafted, invisible, a human signature, inside a machine of extreme engineering. But the real secret is on the outside. Because reinforced concrete has a weakness. It cracks, it absorbs moisture, it ages. So how do you protect a giant structure like this in a tropical storm environment? The answer is almost unbelievable: soapstone. The entire surface is covered in around 6 million tiny stone pieces, not slabs, not panels, fragments, each about the size of a small coin. That's the next contradiction, a massive structure, protected by microscopic precision. These pieces were glued onto sheets, often by hand by women across Rio, and applied like a kind of mineral skin. Many wrote names, prayers, personal messages. So beneath the surface is something deeply human. And this is where an earlier mystery is resolved. Durability. Soapstone is soft when mined, but hardens over time, becoming resistant to weather, water, and temperature stress. It doesn't just protect the statue, it transforms it. Because the surface isn't uniform. It catches light differently at every angle. Morning, noon, fog, sunset. The statue changes, sometimes bright, sometimes muted, sometimes almost dissolving into the clouds, then reappearing, glowing above the city. The science explains the effect, but raises a bigger question. How did they discover this level of material behavior without modern testing? And then comes the final challenge: lightning. Corcovado is one of the most exposed points in the region. Storms hit directly, repeatedly. Without protection, the statue could literally tear itself apart under electrical force. So the structure was designed as a giant Faraday cage, channeling electricity safely through its internal framework into the mountain. That should solve it, but it doesn't fully. Because tropical lightning is extreme, it can vaporize the outer stone on impact. In 2014, a strike destroyed part of the thumb. And this is where the story becomes even more unsettling. Repairs required specialists, engineers who are also climbers, to descend from the head, step onto the outstretched arms, suspended over open air, and rebuild the damage, using stone from the original quarry. Let that sink in. A monument completed in 1931 still depends on its original geological source to remain consistent. And that brings us back to one of the first questions. Durability. We understand the material, we understand the structure, we understand the protection systems, but we don't fully replicate the process. And that's the final contradiction. If we know how it works, why does it still feel out of reach? Because what we're looking at isn't just engineering, it's coordination, precision, material intuition, long-term thinking, patience at a scale modern systems rarely tolerate. Over 1,000 tons, built piece by piece, on a mountain, in clouds, against wind, water, and lightning. Primitive tools, extraordinary results, simple materials, unbelievable performance, no computers, no simulations, yet near-perfect execution. And that contradiction remains. They didn't break physics, they mastered it. And maybe that's the real mystery, not what they built, but what they understood, that we've slowly stopped practicing the same way. Because if this was possible, then what else have we underestimated? We can explain the mechanism, but mastery still stands on the mountain.